All right, we're going to jump right into our next session, moving from cloud cost optimization into building reliable, future-ready applications. Let's give it up for Vasily.
Thank you. So yeah, my name is Vasily. I'm solutions architect here at DigitalOcean. This is a squirrel. Hope you guys see it, and some of you may even recognize it, because this is not my first deploy talk. I already had one this year. And back then, we were talking about how web applications break when cloud providers go down. And my example back then was that in 2012, a single squirrel was all that it took to disrupt the whole data center. So it ended up somehow inside the equipment room, and it bit some lines, and then the whole facility went down. So that was my example. But this time around, I got invited to present a deploy again. And guess what? Again, I'm talking about broken applications. So it looks like my whole gig here at DigitalOcean is hopping on stage and talking about how applications break. But this time, it's a little bit different. So this time, it's not about squirrels or any other critters. This time, it's about us humans. So if, imagine we're running an application with a growing user base, and it has to adjust to this load. We call this load, right? And it looks like not a lot of applications actually live well under the load, so a lot of applications break, not because of just poor design, but mostly because scalability is afterthought. So yeah, scalability is the afterthought. And then how actually do we create the app that doesn't break but shine under load? Let's talk about this. And let's start with the definition. My definition, just for the context of this presentation, scalable app should be elastic, scalable app should be fast to scale, and scalable app should be always available while scaling. So when I say elastic, I mean that cloud provider or infrastructure behind this application should be ready to add or remove resources depending on the load, right? Fast to scale means that it has to add those resources fast, because if you run your application and your cloud provider doesn't back you up with additional resources and time, users will start seeing this strange 50x HTTP statuses, right? Gateway timeout. So we don't want that. And scalable app should always be available. So here, simple example, you want to scale a smaller database to a larger plan. And then as soon as you initiate the scaling request, so the old database should still keep serving your customers up until this bigger database gets provisioned, and only then you have this cutover. So I guess it sounds really simple, but did you ever check if your cloud provider indeed works like this? Now, let me introduce LinkedOut to you. So you guys know LinkedIn, I'm sure. That's a place where users or all of us share news about our successful and bright careers. So LinkedOut is none of that. It's actually the opposite. So this is a place where you laugh at your professional imperfections or weaknesses and career flops, right? And this is the tool that taps into AI sense of humor to build sarcastic profiles, like this one for my friend and teammate at DigitalOcean, Austin Black. His absence makes the team function. So Austin couldn't make it to this deploy. And don't judge AI sense of humor, right? Because I think we as humans are still much better in coming up with punchy and creative jokes. But what does LinkedOut has to do with scalable app? Is this scalable? Nothing, I will tell you. This is a hacky project I put together under time pressure, and scalability was an afterthought, okay? So I thought that would be a great example to take you guys on a journey of turning something that is brittle and fragile into scalable app. Let's show you how it works.
For our sarcastic profile, my friend, Austin Black. Now, to set the stage, we need a little background. Austin lives out in rural Canada. He's got 3 dogs, works as a cloud architect, and he's kind. Next, we'll grab a photo of Austin. Then we'll select serverless inference. And finally, hit the submit button. Normally, the generation takes about 2 minutes. Once it's finished, you'll get a link. That link lets you view, and of course, share your freshly generated sarcastic profile.
So if someone wants to get access, just hit me. So this is not public. But what kind of architecture behind this application? So first of all, you need some compute, right, to run this application, actually. Second, you need something to run the model on. We need model inference. And third thing we need is actually something where we store profile images, right? So for compute, I picked App Platform. Why? Because it's just really developer friendly. The code of Linked Out is on GitHub. So when I work on it, when I make commit, App Platform just goes there, takes the code, builds the app, creates the container, and runs container on my behalf. I have to do nothing, right? So that's convenient. Actually, I use it for, I think, for all my project, like personal project I do on DigitalOcean, just because of convenience, because of auto deploying, right? So this is App Platform, compute. Second, model, inference. So I actually first picked GPU Droplet. This is not perfect, especially for application linked out with like one user. So that's not optimal, and you will understand later why. But that was the cheapest option for me at that point, because that's my DigitalOcean account. I'm not paying for it. It was the simplest, yeah. And then for storing images, I decided to pick Spaces, just the natural choice. Database would have been more clunky, more expensive. How it works. Basically, it has two functions. First, generating the profile, function A. Function B, serving, basically viewing the profile, right? Generating the profile. You point to browser, linked out DigitalOcean solutions, and then you hit the profile generator. That thing goes on to the language model. It sends Austin's photo, and also I do some context, like Austin has 3 dogs. You all saw this. Yeah, and then we get reply back from the model. So this is function A, generating a profile. Function B, we need to store and serve this profile. So profile generator there, it takes all the information we got back from LLM with all the jokes, and then it deploys it as a static app, again, on the App Platform. So here you guys need to understand the difference, dynamic apps and static apps on App Platform, because they are built differently, and they are also scaled differently. So dynamic app is something that has a code to run on the server side. So in my case, it's Node.js. Static is just like HTML with CSS, right? We'll look and get some more differences later. So yeah, viewing, you get a link from a profile generator. You point your browser to that link, and you get to see the profile. It gets served as a static app on the App Platform. And the image, you get served from Spaces. So what happens if I am to release this app tomorrow, right? And it wakes up famous, right? What would happen? Right now, I'm the only user, but it will start picking up users. You guys have any idea? Will it shine or will it break? Right, so it will die for sure. And I know why, because on the App Platform, I run a single container. My model also runs on a single droplet backed by H100. It's a powerful GPU, but it has its limits. And also Spaces, like as an average developer, I don't even know how it scales, right? So do you have to have like one bucket? Does it have any rate limits? Usually, I would not know. So let's take a look at this together. Let's make a few stops here around this architecture. You see this magnifying glass? It points at profile generator. So let's take a look how to scale that. I forgot to mention one thing. Yeah, it works like a chain reaction. When customers start interacting with the profile generator, it puts stress on the model, it puts stress on Spaces, and then the whole app is actually going to crash, like the gentleman suggested. So App Platform, how do we scale App Platform? Right now, we have a single 2 vCPU container there. We have two options. We can scale up or we can scale out. Scaling up, we say, look, I want to keep running just a single container. I want to bump up the size. I want like a 4 vCPU or 8 vCPU container. Today on App Platform, the largest container we support is 8 vCPU container. Is it a lot? Not much. This is option A, scale up. We also call it sometimes vertical scaling. Option B, scaling out. So instead of running just one container, I can say, I want to run same container, same size, but I want many of those. This is what we call scale out. As of today on App Platform, we support scaling out based on the vCPU load in your container. But we're gonna add soon scaling based on request. This is on the roadmap. So what does it give us? Current limit, you can run 250 containers. So if each container is 2 vCPU, it gives us 500 vCPUs. So compare those to scale up. That's much more, right? Good runway. And if we can use combination, we can bump it up to 8 vCPU and use 250 containers, then it will be 2,000 vCPUs. That's already enough to serve like many customers. And how do I actually configure this? I can go and scale it up manually, but no good. This is not convenient. So usually you would enable automatic scaling, auto scaling on App Platform. And this is what I mentioned, actually, the triggers, vCPU and requests. So I also wanted to put this in a little bit broader context because App Platform is like a narrow use case. But usually, I'm part of a solutions team. Like getting on calls with customers is our job. So I get this question asked quite a lot, like what should we use? Should we scale out or should we scale up? And I tend to say usually scaling out gives you better runway, is a little bit better, but it introduces a lot of complexity. So you see here, you need to have a load balancer. Usually it's taken care of, like on App Platform, that's included. But the biggest downside is like, imagine you run database here on all the instances and part of the database on one of those instances. It goes away, it gets auto-scaled, and then your database is like, you lose part of it. That's not acceptable. So this part here, you have to make it, you don't store persistent data there. You have to take it out. And that's architectural complexity. While if you scale out, or if you scale up, if it's vertical scaling, you can still use this single instance, right? You don't have that much resources, that many vCPUs, but the architecture is really simple. So every use case is different. And when I get customers asking, I'm not saying like, oh, use this or that. We need to look like what you guys using and what's best for you. But that's enough 101. Let's look again at the architecture, right? So my solution for App Platform would be two things. First, I enable auto scaling, horizontal auto scaling, right? And second, I need to pick dedicated vCPUs. App Platform offers two options, dedicated vCPUs and share vCPUs. So dedicated vCPUs, you need that as a prerequisite for enabling auto scaling. And yeah, that scales the profile generator. I can turn one arrow from red to green, and yeah, profile generator check. Next stop. Next stop is model inference. Believe it or not, again, the same thing. You have two options, scale up or scale out. Right now, I run it on a single droplet backed by a single H100. Scaling up, there's just one option. You can scale up to an 8 GPU droplet. There's nothing in the middle, 1 or 8, right? And when you're scaling up, you're enjoying this really fast 900 gigabyte per second NVLink GPU to GPU, right? This is if you want to scale up. If you want to scale out, you can add more droplets. And then those get interconnected by Rocky V2 400 gigabit per second backend network. So scale up, you see here on this slide, you see profile generator interacts with few GPUs and you run your model across all those GPUs. But important question, how do I run a model across many GPUs? Don't worry, I'm not going to touch it here. So that's the topic for like a separate session. But I give you some homework. That's the first and only place I give you some homework in this presentation. So this is a really good article if you follow it. They discuss how to build really large clusters, like 1,000 K clusters, and you learn things like tensor and pipeline parallelism in there. That's important to know if you want to scale. But even looking at this architecture, scale up, right? It doesn't look, or it looks less like architecture, but it looks more like a well-paid and a full-time job, because you will have to hire someone to babysit this cluster. And also look at the price tag. So I converted this to pounds because we're in Britain, so it's 12K pounds per month for this GPU droplet. This is like being the only employee at LinkedOut, like I cannot foot the bill probably. So that's quite expensive. Do we have any solution? Do we have any alternative on DigitalOcean? So I thought that I would be speaking like maybe before lunch, so and I would talk about serverless inference, but a lot of guys spoke about it already. So yeah, that's the solution, easy. So my solution here would be to swap GPU droplet for serverless inference. There was just one obstacle. GPU or serverless inference didn't support images before. It was text only. Now it should support images. And you can pick the models like OpenAI, Anthropic, Meta. Very important, why is it good for LinkedOut? Because it's usage-based, it's not hour-based consumption, and it's also auto-scaled. Okay, so we don't have to think how to scale it, or you don't have to think. We have to think with DigitalOcean. So make us work. And also this new logo for AI/ML on DigitalOcean with the sparkling stars in the center is like some magic going on there. So that's the scaling magic. Yeah, let's use the scaling magic and let's hope it doesn't end up as a support case, which sometimes happens as well. So let's say model scaling or inference scaling is done. The solution is to swap GPU droplet for serverless inference. One more arrow gets green. Let's look at Spaces quickly. So Spaces is quite simple. It does, oh, I keep saying this, but it really does two functions. So one function is uploading files. Another function is, you need to get your photo of Austin, so downloads. How do we scale uploads? For uploads, there's like one limit you need to know. We support 1,500 RPS per IP across all buckets. That's the rate limit. So if you do uploads, this will be a rate limit. How do we scale that? Because it's per IP address, and if you remember, this is profile generator uploading files to Spaces. We just need to get more IP addresses. So we get more containers. Those containers land on more nodes, and then we get more IP addresses. That's how it gets scaled. That's how you circumvent this rate limit. This is uploads. For downloads, it's even easier. CDN. Few folks already mentioned this. You can enable at no additional cost. And basically, like virtually, your rate limit is unlimited there. So Spaces is easy, and I can get 2 more arrows green. CDN on, that's my solution. Multiple IPs solution on the profile generator side. Then final stop. How do we scale the static part of the app platform? Again, quite easy. Again, this is CDN, so you just serve this HTML plus CSS. CDN takes care of that. But this is the first time, and this is an important place, first time here we face not just the service limits, like app platform limit or Spaces limit. We face and we hit some platform limits. For example, when profile generator goes and deploys the profile as a static app, it uses API. And you can make up to 5,000 API calls per minute per token on DigitalOcean. That's for the whole platform. If you need more, contact the support, but this is a limit you need to keep in mind. Also, account limit. You can, by default, have just 10 static apps per account on DigitalOcean. So this is not really scalable. And this is, to be honest, this is a design flaw from my end, right? I should have deployed each profile not as a separate static app. But instead, I should have deployed just one static app with like many pages. But that's, again, scalability was an afterthought. I just fall for the simplest thing. Finally, cost. Each static app costs you $3 per month, and 3 first are free. So this is not also really scalable. So my solution here would be to actually rework the architecture a little bit and deploy as a single static app with multiple pages. Okay, that's on the roadmap. This is not something I implemented yet. But let's imagine I implement it, and then look, all arrows are green, and we have the whole architecture check. So for linked out, for whole architecture, when I say it's elastic, it's fast to scale, and it's always available. That's the definition we had in the beginning. I would like to make one more stop before I let you guys go, and this is databases. Even though my application doesn't use databases, this is, again, one of the most asked questions when we get calls with customers. They say, look, I have a database. How do I scale it? Right now on DigitalOcean, we offer 6 engines, and each of them falls into 2 big groups: relational database or non-relational database, SQL, NoSQL. Something like Postgres is relational. Those databases are really not good scale-outers. They scale vertically, but scaling out is hard because they work with transactions usually, ACID compliant, all that stuff. So you can scale out reads. You can add read replicas, but writes will only go to a primary node, right? This is relational. On the non-relational side, we have OpenSearch, we have Kafka, we have MongoDB. So those databases are good scale-outers. So on DigitalOcean, I believe you can scale those clusters, some of them up to 50 nodes, and then reads and writes will go to all of the nodes of the cluster. It's much better scaling, but they are based, they are not ACID, they're like less good for transactions. So there's always a choice, always a trade-off. Storage autoscaling, yes. I think it was announced already that we're going to get storage autoscaling on all database engines. To sum this up, as you see, scaling an application in the cloud is not an easy task. You have to take many different factors into consideration. Service limits, like that 250 containers on app platform, then platform limits, something like API rate limit. DDoS protection, this is not something we touched, but if your app generates a lot of traffic, it may trigger some DDoS protection workflows, so you need to understand what are those thresholds. And then network, like all the components I was talking about, they are not just in vacuum, they are interconnected, so you should also know like what kind of networks interconnect them and what's the speeds. And finally, cost, usage-based versus time-based, right? You should know this difference because if you don't pay attention, if you don't know, you may end up on websites like this. Serverless horrors. So this is one of the websites where they collect horror stories about customers getting sudden huge bills from their cloud providers. And 2 solutions, I think Akshit mentioned them in his presentation: setup billing alerts, and also setup. Or just go and look. We have like a really nice billing page where you see all the services and you can control your cost there. That's it from my side. Like I hope I arm you guys with some knowledge about scaling applications so you can go build scalable apps. Thank you.